So let's take volume and move it from prisms into pyramids and cones. Looking at when they taper to a point, we've got a different formula, but it's related. So it's not going to be a difficult calculation. When we consider a cube with side lengths of 2, and there's an image of it here, the center of the cube is located and the segments are drawn to each of the 8 vertices. So you can see the center of the cube going out 8 different directions, 1 to each corner. So this created a pyramid, and the pyramid on the bottom is the shaded section there. Now the original cube would have been 8 cubic centimeters because it's 2 in every direction. So the base is 2 times 2, that's 4, times the height is another 2, that's 8. But we want to figure out how many of those pyramids on the bottom here would fit into the original cube. There would be 6 of them because the base of the pyramid could be drawn on any one of the 6 faces of the cube. And so there are 6 total pyramids that end up in the center. So if we take the 8 volume for the cube and divide it equally 6 ways, every pyramid must be 4/3 centimeters cubed. All right, so let's keep that in mind as we go through this. So in the prism that we were looking at, the height of the prism would have only been 1 because it went to the center. Right, so if we're looking at fitting a prism into a rectangular prism, a pyramid into a rectangular prism of height 1, what it ends up doing is it ends up being 1/3 of the volume of the prism. All right, that's the formula that we're going to apply. So what we can do to get that as a full calculation here, the prism we're looking at in this rectangular section would be 2 times 2, that's 4, times 1 is still 4. So the volume of the prism is 4. If we didn't know the fraction to apply to it, what we could say is that the pyramid is 4/3, and so the fraction that I apply to the prism would be 4/3 divided by 4, which is 1/3. So for any pyramid, if we take the related prism of the same height and multiply by 1/3, we will get the pyramid volume. So that'll happen here. If you take a pentagonal prism and you turn it into a pyramid, the formula just puts a 1/3 in front. Even if you take a circular prism, otherwise known as a cylinder, you can put a 1/3 in front of that and it becomes a cone. So any prism or cylinder will be calculated by putting a 1/3 in front of the volume formula. All right, so we have this problem here with the pyramid in Egypt, square base 756 and a height of 481. So if I was doing a prism with 756 and 481, I would just multiply 756 by itself to get the area of the base and then times the height. But because it's a pyramid, we're going to also multiply by 1/3. And so when I enter that information into the equation, 756 squared would be my base, 481 would be my perpendicular height, and then the 1/3. Now note, this 481 is the perpendicular height to the base. If I was given this slant height, I would have to use that along with Pythagorean theorem to figure out what the height is. So you could see a theoretical problem. I'll just show you an example of this. You could see a theoretical problem where you know the slant height. I'm just going to make something up. Let's say it's 500. And you don't know the perpendicular height that you need, so that would be x. And so what you would do is you would draw a right triangle that goes from the center to the base, and then you would take that slant height and use it along the center of the face. And so what you would have is this right triangle here. Now this base of that triangle would be half of the square section. So in this case, that would be 378. And you could then do Pythagorean theorem and figure out what the height is. Okay, so if you're told the height, then you just use it. But if you're told the slant height, then you'd have to figure out what the actual height of the pyramid is off of that. All right, so this one's going to come out to, with a final calculation, about 92 million feet cubed. All right, exercise 3, cylinder of solid material, radius 4, height of 10. So I've got a radius 4, which helps me to get the area of this circle. And I've got a height of 10, which is going to be the height of the cylinder as well as the height of the cone. So we want to know the volume of the remaining material. So that would be the part of the cylinder that the cone doesn't fill. All right, so if we get the cylinder first, that's the area of the circle times the height. That's going to be 16 pi from doing 4 squared and then times 10. So 160 pi. Then to get the area of the cone, I'm going to do the same thing but times 1/3. So that would be 160 pi over 3. So to get the part that's shaded, the outer part, I would take the area of the volume of the cylinder and subtract the volume of the cone. Okay. So if I do 160 pi minus 160 pi over 3, that's like 1/3 of 160 pi. So this is a whole 160 pi minus a third would be 2/3 of 160 pi, or 320 pi over 3 times pi. Now, however you arrived at this doesn't matter. You you might convert this to 480 over 3 and subtract 160 over 3 and get 320 over 3 that way. So the way you manipulate those fractions doesn't really matter to me, as long as you end up with something in terms of pi. Then to go to the nearest cubic inch, which I didn't do here, you would put that on the calculator and get that answer. But I want you to keep pi as long as you can, because the earlier you round the pi, the more rounding is incorporated and the less precise your answer is. Now, one other note on this one, again, just like I showed you on the pyramid, it's possible that you know the slant height of a cone. And if you knew this height here, you would then have to solve for, let's say we didn't know the 10, right? And you needed the height of the cone in the cylinder. Well, if you had the radius or the diameter and you had the slant height, then again, you have a right triangle that you could apply Pythag to and figure out that missing dimension. So height and slant height are not the same thing. All right, final exercise, exercise 4. We've got a pyramid, and what we know about it is that the volume equals 216. So we'll take that and incorporate it into our calculations. Now it's a cube, and so if the volume of the cube is 216, then that must mean that 216 is equal to AB to the third power, right? Because it's a cube, so all of the dimensions are the same. So if I just solve that, I get AB equals 6. So that's the whole segment here, which means that the AC segment is 3. And I think I'm going to need that for this pyramid. So what it looks to me like is the pyramid has a triangular base with a right angle and a 3 and a 6, right? So that's the base of my pyramid. And the formula for volume of a pyramid is 1/3 times the base area times the height. Well, the height of the pyramid is also 6, so I'll put that where the height goes. To get the area of the base, it's just 1/2 base times height, little b, base times height. So that's 1/2 of 18, which is 9, and then 1/3 of that answer. So if this is 1/3 of 9 is 3 times 6 is 18, so I have 18 cubic centimeters. Okay, so we use the cube volume to get the dimension, and then do a separate problem to get the base of the pyramid and put that into the pyramid formula.